We will continue the course for commercial mechanical inspector M2. Now we are in module 11 in hydronic piping. The recommended study time is 19 minutes. And module 11 required reference International Mechanical Code Chapter 3 and Chapter 12. Hydronic piping. Illustration 11a is hydronic piping. When we talk about hydronic piping, we are talking about a system that includes the piping, fittings, and valves used in building space conditioning systems, applications, including heating water, chilled water, steam and steam condensate, brines, and water antifreeze mixture. Chapter 12 contains the provision that govern the construction and installation, alternation, and repair of all hydronic piping systems that affect reliability and serviceability, energy efficiency, and safety. Piping support. This International Mechanical Code, Chapter 3, Section 306. Pipes need to be supported or they will sag bonus around from water hammer. Bounce and possibly break with seismic activity or simply due to their own weight. Illustration 11p, hanger support. Piping hangers should be sized appropriately to carry the required pipe load. Hanger must be made of material compatible with the pipe, and Section 305 of the code explain the requirements of piping support. Pipe that is more flexible will sag more in between hangers. It therefore requires more hangers. Table 305.4.
Table 305.4. Table 305.4 gives requirements for hanger spacing. Read through our condensed version grouped and organized by spacing.
Here, this is a piping material. Okay. PERT, PEX, PP, CPVC, and the maximum horizontal spacing and the maximum vertical spacing. This is a table. Okay, illustration 11c, table 305.4. Condensed polyethylene and lead pipe were removed from the table because those two materials should avoid it. Illustration 11d, striker plates. This is striker plates. Okay. If pipe is installed within 1.5 inch of the nearest edge of structure components, 16 gauge protective shield plates are required to protect the pipe from damage. Hydronic piping, general, International Mechanical Code 2021, Chapter 12, Section 1201, hydronic piping system.
Hydronic piping systems. Most people associate pipes with plumbing systems. This chapter covers the construction, installation, alteration, and repair of hydronic piping systems. Hydronic piping systems carry water or other fluids specifically for heating and cooling applications. The fluid could be steam, hot water, chilled water, steam condensate, and antifreeze solutions. Remember that plumbing systems are covered in another code, the International Plumbing Code.
Materials, International Mechanical Code 2021, Section 1202. Most of the requirements concerning material are by reference standard listed in tables 1202.4 and 1202.5. Used parts who, when used in construction, need to be clean and approved for refuse. Think about it. Piping materials and component should be selected for compatibility with the temperature and pressure of the fluids in the system. Joints and connection, International Mechanical Code 2021, Section 1203. After proper material is selected for the system, the joints and connections are the most common place for the system leak. Joints and connection require the approval of code official. Illustration 11E, adjoining differing piping material. It is important that joints between different piping material be made with approved adapter fitting. Illustration 11F, pipe end requirements. Pipe should be cut square, reamed and chamfered, and be free of pores and obstructions. Pipe ends must have full pore opening and not be undercut. Identifying joint types. Let's look at typical joining methods used in hydronic piping installation. Illustration 11D, copper piping connection. For copper pipes or tubing approved joining method include brazed, soldered, flare joints, push fit joints, press connect joints for connecting sections. Here, illustration 11H, steel piping connection. For steel pipes, a groove, threaded, weld, or flanged connection is acceptable. Illustration 11I, ABS, CPVC, and PVC piping. PVC piping. When using the material, a solving cement is an acceptable connection in addition to threads. Here, illustration 11J, PIX piping. For PIX piping, here we can use compression type joints. This compression type joint. Okay, this is a PIX T, and this crimping ring, and this is a crimping tool. And there is another method, this push fit joints. This push fit joint, this shrinkable bit T. Two types of connection are acceptable for PIX: compression type joint, this one, and push fit joint. And the example of the push fit joint is coupling splice products known as sucker bite connection sold at Home Depot. Sucker bites also make other kind of fittings. Illustration 11K, polyethylene and polyethylene piping. These materials can accept heat fusion, mechanical or compression sleeve joints connection. Pipe insulation, International Mechanical Code 2021, Section 1204. Pipe insulation requirements are specified in the International Energy Conservation Code, Fast facts. For our studies here, pipe insulation outside of the plenum can have a maximum flame spread index of 25 and smoke developed index less than 450 valves. International Mechanical Code 2021, Section 1205. There are locations in hydraulic systems where the code requires valves Additional valves may be used, but these locations are required. Let's look them over. Study tip, code required, valve location, the supply and return side of heat exchanger, a building supply and return of central utility system, a connection to any pressure vessel on both sides of pressure reducing valve, on connections to mechanical equipment and appliances, on connection to non-diaphragm type expansion tank. Here, this is the pressure relief valve. Illustration 11L, pressure relief valve. A pressure relief valve set at the maximum pressure of the system and required on the low pressure side of hydronic system that has been reduced in pressure. Piping installation, International Mechanic Code 2021, Section 1206, except for portions of the system that are underground or under floor, hydronic piping system must be able to fully drain. This illustration 11M, low point drain. This every time the pipe offset down and then up again, the code requires that a low point drain must be installed. Make up water. Portable water systems are often used to make up water lost in hydronic system. Where portable water is used for make up water, backflow prevent is needed.
Makeup water. Occasionally, water is lost from a hydronic system. Now, there are many ways this can occur. Some examples include strainers that are blown down to remove debris, or solid separators that are flushed out to remove settlement, or pressure relief valves. They open and dump water. Small leaks can develop, and new connections are made. The larger the system, the more likely that at least one of these events is always happening. And to make up for the losses, makeup water is provided. In a small system, that may be a manual process. But in a large system, makeup water is often provided. But where the potable water connects to the hydronic system, backflow prevention is needed.
Sometimes hydronic piping need to be protected from the building, and sometimes other building elements need to be protected from the piping. Whichever the case, the code prescribes requirements to ensure this protection. Illustration 11N, 250 degree plus. If the exterior temperature of the pipe exceeds 250 degree Fahrenheit, a clearance of 1 inch to combustible material is required. This very important point that if the exterior temperature of the pipe 250, the exterior temperature here outside, if it exceeds than 250, it must be far minimum 1 inch from the combustible material. Think about it. Building materials that can use the piping material to degrade a corridor or interfere with the operation of the system are not allowed to be in direct contact with the pipe. Water hammer, mentioned earlier in the module, typically occurs when following water is suddenly stopped, usually by quick closing valve. Illustration 11. Water hammer arrestor. This is a water hammer arrestor. Water hammer arrestor should be avoided by controlling the flow velocity. In the case of quick closing valve, a water hammer arrestor should be installed. Quick closing valve and water hammer are more common in plumbing systems than they are in hydronic piping.
Expansion and contraction. Damage can occur in piping as it expands and contracts due to changing temperature. 100 feet of steel pipe will grow 1/4 of an inch for every 30 degrees Fahrenheit change in temperature. If there are no thermal expansion loops or fittings installed, a long length of steel piping could be subject to enough stress to even break. Thermal expansion protection is required by the code, and the formation of condensation on the exterior of piping must be prevented.
Transfer fluid. This is an International Mechanical Code section 1207. Illustration 11b. Transfer fluid. Transfer fluid in a hydronic system refer to the fluid and the pipes used for heat transfer, make up water supplied to the system need to be compatible with the transfer fluid. The flash point of the transfer fluid must be at least 50 degrees Fahrenheit above the maximum system operating temperature. Think about it, flash point increase when under pressure, so system pressure must be taken into consideration when determining compliance to this requirement. This International Mechanical Code 2021, Section 1208. Hydronic piping system need to be hydrostatically tested before they are put into service. Fast facts, hydronic piping must be tested 1.5x the maximum system design pressure, but at least 100 psi for the least 15 minutes. Embedded piping, International Mechanical Code 2021, Section 1209. Pipe is often embedded in concrete to form radiant heating panels such as radiant floor or snow melt system. Here, illustration 11q, embedded piping material requirements. Embedded piping material are limited to standard weight steel pipe, type L copper tubing, polybutylene or other approved plastic pipe, or tubing rated at 100 psi at 180 Fahrenheit. While the pipe is being embedded, it should be maintained at the proposed operating pressure. Approved joint for embedded piping, because the joint of embedded pipe will be accessible once installation is complete. There are select joints allowed for each piping material. Study tip: approved joints for embedded piping: steel pipe, welded joints by electrical arc or oxygen acetylene, copper tubing brazed joints, polyethylene continuous length of heat fusion joints, polyethylene of raised temperature PERT, joints of continuous length of hydronic fittings listed in table 1202.5, cross-length polyethylene PX, joints of continuous length of hydronic fittings listed in the table 1202.5. Understanding design. Even though the code allows copper crimp rings for PICs to be embedded in concrete, it is not the best practice since they can deteriorate from the corrosivity of concrete. Yeah, this is not safe. Required insulation.
Required insulation. Insulation is required underneath radiant floor heating systems per the International Energy Conservation Code, unless it is demonstrated that the insulation would have a negative effect. As an example, with concrete foundations, an asphalt expansion joint or other insulating material is needed to isolate the edge of a heated slab from foundation walls or other slabs.
Plastic pipe, ground source heat pump, loop system. International Mechanical Code 2021, Section 1 to 110. Ground source heat pump are used on projects to provide comfort, heating, and cooling. They capture the heat from the ground to heat the building or reject the building heat into the ground to provide cooling. Illustration 11R ground source heat pump. Ground source heat pump used the refrigeration cycle to reject heat or extract heat from the ground. They accomplished that through ground loop piping and tubing that is buried into the ground, often drilled to hundreds of feet depth. Reused material are not permitted in ground source heat pump loop systems. Also, any part used should be suitable for burial. Fast facts: only plastic piping material are allowed as listed in Table 1210.4. Joints permitted for use. The joints used in ground source heat pump loop are the same as that for other systems using plastic pipes, but if used underground, they should be approved for burial. Illustration 11S polyethylene PE pipe. Polyethylene PE pipe plastic pipe is the most common pipe used for ground source heat pump applications. The joints are made by heat fusion, electrofusion, or using stab type insert. Illustration 11T heat fusion joints. Heat fusion joints are made using socket fusion, saddle fusion, or butt fusion joints. The joint surfaces are heated to melt temperature and then joined together and distributed until cool. Illustration 11U electrofusion joint. Electrofusion joints are made by sourcing the pipe to expose virgin resin, then a heating coil is placed around the joint's location and heated by electrofusion control unit. The electrofusion joints are used where direct heat fusion is not possible, for example when cutting into a T or a valve in the existing pipe. Illustration 11V stab type fittings. This stab type fittings are a mechanical fitting system. Pipe ends are chamfered and inserted into fittings to full depths. They have been popularized by Shark Bite brand for pigs, sold in many hardware stores. These fittings are usually used for smaller piping, 2-inch.
Entering the building. Where the ground source heat pump piping enters a building, the pipe needs to be identified with the words ground source heat pump loop system. Also, any antifreeze used in the system should be listed by name and concentration.
Connection header trenches. Connection header trenches are the trenches that contain the header piping for all the individual group loops. Often the loops themselves are continuous piping. This is the header. Illustration 11W connection header trenches. Connection header trenches are where the connections are, so before they are backfilled, the assembled loop system required to pressure test with water at 100 psi for 15 minutes with no observed leaks, flow, and pressure loss testing is also required here. If the flow and the pressure drop differ from the calculated design by more than 10%, the chaos must be identified and correct it. Let's see the quiz. Okay, a joint that is made by joining copper with an alloy melting 1200 Fahrenheit is called brace joint. The maximum horizontal spacing of piping support for plastic pipe except polyethylene that is 1 to quarter inch, 1 and quarter inch and larger is 4 feet. Which of the following is permissible in the effort to gain access to for inspection, service, repair, and replacement of fan-powered cooling unit? It is removing shielded water pipe connected to the cooling unit. Next, the system design pressure of hydronic piping system is 60 psi. What is the system pressure required for the hydronic piping? It's 100 psi because it's 1.5 of the more than 1.5 of the testing of this one of the pressure of the system pressure 1.5 more. Next one, which of the following location is not required location for shut off valve? It's upstream of strainer, no need for shut off valve. So now we finish the module for module number 11 for hydronic piping. The next module it will be heating appliances, this module number 12.